and welcome to our first partial project. We are from Group 11. Our teacher is Edgar Orozco, and we are Ana Paola, García, Erick, Omar, García, and Luz Virginia Raygoza.
A rational function is any function which can be defined by a rational function, in which both the numerator and denominator have polynomials, and in this case the denominator has a variable that can be x.
Now we gotta know the population of rabbits in 2006 and 2020. So to do that, we thought like 2000 is 0, 2001 is 1, t is 1, 2002 t is 2, and so on. So 2006 t8 is equal to 6. So we we evaluated in our function, and 200 times 6 minus 120 over 6 plus 0.5, and we did the stuff and we got 64. So the population in 2006 was 64 rabbits. And in 2020 we did the same, so t equals to 20, and we evaluated in the function 200 times 20 minus 120 over 20 plus 0.5, and we did everything and we got 189.26, but you can't have 0.26 rabbit, so we got 189 rabbits. This is mathematically, and this is like logic.
Okay, so here we have our rational function. From here, we're going to get a vertical asymptote, a horizontal asymptote, possibly a slant asymptote, and if there are some, intercepts in the axis. We're going to start finding the domain.
If we can remember, the domain is all the numbers that can't make this equation indefinite. In other words, every number that doesn't make 0 the denominator, right?
So here we have that this number that makes indefinite our equation is minus 0.5, because minus 0.5 plus 0.5 is 0. Okay? This means that it's indefinite.
So we can say that x belongs to every real number except for minus 0.5, which is a specific term.
If in this function we have the variable of the numerator and the denominator with the same exponent, in this case 1, we can infer that all lies in a division of the coefficient in the numerator and the denominator. Here we have the case of 200 over 1, which is
200.
Okay? Now we have to multiply 200 multiplied by minus infinity is minus infinity minus 120 still minus infinity over minus infinity plus 0.5 is still minus infinity. So we're going to follow the same process like we did with x approaches infinite. It lies in a division of the coefficient in the numerator and the denominator. So we have that 200 over 1 is 200. So now we have proved that our horizontal asymptote is 200 because we have evaluated it in minus infinity and infinity. This is our horizontal asymptote. Do you remember this term? This means that in the domain we're not to include this term, minus 0.5, which could be our horizontal asymptote. To find it or to prove it, we're going to deduce the same as the limits, but this time with this term. Look at it. We have
the limit. We're talking about domain, so x approaches minus 0.5 from the left because it's approaching from minus infinity. Okay. We're going to evaluate it in that function. P of minus 0.5 from the left equals 200. Okay. We have it. We're going to multiply 200 by 0.5 minus 0.5 equals minus 100 minus 120 equals minus 220. So then we're going to look for the result in the denominator. We have minus 0.5 from the left plus 0.5, which is 0 from the left. We don't have a complete irrational function
because here in 0 from the left we have some decimals and Canada.
So we're going to say that it equals minus infinity because we have a positive and a negative. So it's minus infinity.
In this specific function, we can see that the domain is going to be x includes all real numbers except 0.5. Why? Because the vertical asymptote is going to be at that exact point, at 0.5, 0. And for the range, we can see that it's going to be y includes all real numbers except 200, because that's where the horizontal asymptote is located. As for this specific problem, the domain is going to be the same as the range. The domain and range are both going to be all numbers including from 0 to infinity.
Wait, what? This is our proof that we have a vertical asymptote.
The specific aim behavior for this particular function would be as x approaches infinity, y will approach 200. And while x approaches minus infinity, y will still approach 200. For any given function, a function is going to increase or is going to be increasing when y values increase as the x values increase. And a decreasing function is going to be when the y values decrease as the x increases. So, in this particular function, we can have both. But for the given problem, we can see that this is going to be an increasing function. In this particular problem, it's always going to be increasing since unless the rabbits begin to die. But as long as that doesn't happen, and we just count the amount of birds that the rabbits have, then it's gonna be an increasing function.
Oh, I didn't saw you there. So, we're about to graph our rational function. Do you remember? Our vertical asymptote was at minus 0.5 and our horizontal asymptote was at 200. Okay, now that we have graphed our asymptote, vertical and horizontal, now we have to put our intercepts in the axis. So our graph should be something like this. Okay, now we have graphed all our functions.